Hi viewers, welcome you all. In this video, I am going to explain User Datagram Protocol UDP. Figure 1 shows the relationship of layers and addresses in TCP/IP. Also, it shows protocols of the layers. As you all know, physical addresses are used in data link layer. Logical addresses are used in network layer. Port addresses are used in transport layer. These three addresses are the most important addresses. In addition, one more address, that is specific address, is used in application layer. Okay. So in this session, we will see the protocols of the transport layer. To begin with the protocols of transport layers, so the very first I'm going to explain a user datagram protocol, that is UDP. Okay. What are the protocols of the transport layer? As far as the transport layer is concerned, there are three protocols involved. You can see the figure 1. UDP, that is User Datagram Protocol, TCP, Transmission Control Protocol, SCTP, Stream Control Transmission Protocol. Okay, in this video, we are going to discuss User Datagram Protocol, UDP. Okay. As I already told, there are three protocols involved in transport layer. The protocols are User Datagram Protocol, UDP, Transmission Control Protocol, TCP, Stream Control Transmission Protocol, SCTP. Okay. Now we will discuss User Datagram Protocol, UDP. Okay. So some introduction about User Datagram Protocol, UDP. So UDP is a connectionless, unreliable TCP/IP transport layer protocol. So here they are using the term connectionless, unreliable. What do you mean? What do you mean by connectionless here? Unlike TCP, UDP does not establish a connection before sending data. It just sends. Because of this, UDP is called connectionless. UDP packets are often called datagrams. Okay. Moreover, UDP does not provide error correction and is therefore an unreliable protocol. Okay. It provides process-to-process communication. UDP is very simple protocol. Sending a small message using UDP takes much less interaction between sender and receiver than using TCP. UDP is a convenient protocol for multimedia and multicasting applications. Okay. I hope you all know port addresses, that is port numbers. So port numbers, types of port, so that's all you might have studied before. There are three types of port addresses. What are the three types? Well-known port numbers, registered port numbers, dynamic port numbers. Okay, here UDP uses port numbers as the addressing mechanism in the transport layer. That is the important point. User Datagram protocol uses port numbers as the addressing mechanism in the transport layer. You can see table 1 here. Table 1 shows some well-known port numbers used by UDP. So what do you mean by well-known port numbers? Well-known port numbers range from 0 to 1023. So now you can see the table 1. The table 1, you can see the port numbers and the corresponding protocols also. So please go through it. Okay, now we can see the user datagram packet format. Already I told, in UDP, packets are called user datagrams. Datagrams have fixed size header of 8 bytes. So figure 2 shows user datagram packet format. Right? As shown in figure 2, UDP datagram consists of a datagram header and a data section. Furthermore, UDP datagram header consists of 4 fields, each of which is 2 bytes, that is 16 bits. What are the fields in header? What are the fields in headers? Source port number, destination port number, total length, checksum. These are the 4 fields in the header, datagram header. Source port number specifies the port of the device sending the data. It is 16 bits long. Port number can range from 0 to 65,535. Second field, destination port number, it specifies port of device receiving the data. It's also 16 bits length or long. Then third field, total length. Total length field specifies number of bytes comprising UDP header and UDP payload data. Fourth one, checksum. Checksum field allows the receiving device to verify the integrity of the packet, header and payload. This field is optional one. Okay. See the figure on the left bottom corner of this slide. That is figure 3. Figure 3 shows UDP encapsulated in IP datagram. So a user datagram is encapsulated in an IP datagram. So from this figure 3, we come to know that UDP datagram length is equal to IP datagram length minus IP headers length, isn't it? So these are something about the user datagram format and their fields. Okay. Generally, a client process initiates message exchange with a server process. Once a client contacted a server, the server knows the client's port because port number is available in the message header. The server accepts messages at well-known port that they're ranging from 0 to 1023. Okay. To generalize this idea, only a single well-known port can be used. A client sends message to port mappers, well-known port. So please take note the term port mappers. So a client sends the message to port mappers, well-known port. So client, the message is for asking the port. It should be used to talk to the whatever services. Then port mapper returns the appropriate port. In this strategy, it is easy to change the port associated with different services over time. Okay, here your port is implemented by a message queue. A port is implemented by a message queue as explained in the given figure 4. Please have a look at figure 4. So see the figure showing the message queue. Okay, here, when a message arrives, the protocol, that is user datagram protocol, appends the message to the end of the queue. If the queue is full, that is already many packets in the queue, the new message will be discarded because there is no flow control mechanism in user datagram protocol. If there is a flow control mechanism means so maybe the receiver will tell the sender to slow down the sending the data. But here, no flow control mechanism in user datagram protocol. So when an application wants to receive a message, one is removed from the front of the queue. If the queue is empty, the process blocks until a message becomes available. So how to ensure the correctness of the message? So here the checksum comes into picture. So checksum ensures the correctness of the message. So using the message queue, a port can be implemented as shown in figure 4. Okay. Okay, here, pseudo header, the term. So here you can see pseudo header. So already told, checksum is the error detection method. In this method, input will be UDP header, contents of message body, and pseudo header. So pseudo header consists of three fields: protocol number, source IP address, destination IP address, plus the UDP length field. So pseudocode consists of primarily three fields, but anyway, UDP length field also another field. So we can say protocol number, source IP address, destination IP address, plus UDP length field. With the help of pseudo header, we can verify that a given message has been delivered between the correct 2 points. The purpose of pseudo header is to verify that UDP datagram has reached the correct destination. Okay, now you can see here, you can see the pseudo header format. Pseudo header format. So pseudo header is prepended to the user datagram for the checksum computation. We already know UDP format, that is data plus UDP header. Here furthermore pseudo header will be added. Pseudo header format, it consists of source IP address 32 bits, destination IP address 32 bits, protocol 8 bits, UDP length 16 bits, then the 0 8 bits. So this is the pseudo header format, right? Then finally we can see the applications of user datagram protocol, UDP. In the initial slides, I already gave the introduction about the user datagram protocol. So UDP is a connectionless and unreliable protocol, we already told. So UDP is suitable for a process that requires simple request response communication with little concern for flow and error control. In UDP, there is no flow control mechanism and error control mechanism. So UDP is suitable for a process with internal flow and error control mechanisms. UDP is suitable for transport protocol for multicasting. Also, it is used for some routing, UDP is used for some route updating protocols such as routing information protocol or IP. Furthermore, UDP is used in conjunction with real-time transport protocol, RTP. So these are the some major applications of user datagram protocol. Actually, as far as the protocols of the transport layer are concerned, there are three protocols involved: user datagram protocol, transmission control protocol, stream control transmission protocol. So among these three protocols, in this video just now we discussed user datagram protocol, UDP. In my next video, I will explain transmission control protocol and further SCTP, stream control transmission protocol. So you can go through the standard textbook for further information These are some reference books which I used. Okay, thank you very much for watching this video. Thank you.